similar triangles, it shouldn't take you that long. You shouldn't spend half your test just drawing similar triangles. So the first thing I'm going to look for is I'm looking for x. X is in this triangle here. Well, that triangle there is similar to the big triangle because it does have a 90-degree angle here. And maybe I'll put that in green so it pops a little bit more. That's my 90-degree. And it also, by the reflexive property, R is congruent to R. Now, to speed up your drawings, because some of you kind of like in your head are picturing how to flip it, and then you draw it and it doesn't quite look right. Well, what I would do to redraw both of these triangles is first I would draw the big triangle. All right, as close to the big triangle as I can, knowing that this is 90 degrees. And I'll go ahead and label the information. This is 60, this is 32, this is 68. Now we know the small triangle is similar to it. So what I'm going to do, without even thinking about how to flip it or anything, I'm going to draw that exact same shape, just smaller. All right, I drew the exact same shape, just smaller. And now I know that they share angle R. So I could put that right. Where's my R on this one? R is here. And it's going to share that angle here. Well, an easier way to do that might be also, if you look at that 32 on the red triangle, guys, I don't care if you're done or whatever, you should either be paying attention or you can just blank off into space. All right, this 32 is my hypotenuse. So I'm going to label my hypotenuse as 32. Then I'm going to notice my short side is x. In other words, this x is between the R, and that h. So I'm going to mark this as x, and then the other one has to be h. You shouldn't spend a whole bunch of time drawing your triangles. You should go really quick. They're all similar, so just draw them similar, and then put the information on after. All right, so now that we know that, we're going to have a scale factor. Our scale is going to equal 32 over 68. I had a great question, and it was, what does it reduce down to? If you're spending a whole bunch of time coming up with what it reduces to, just use 32 over 68 in your equation. You have calculators anyway. Yeah?
So you don't need to label like the letter of the triangles?
You do. No. The only time you need to is if I ask you what two triangles are similar. So let's say I ask you to do a similarity statement. Then you might want to do, okay, T, M, R, this was my R value, this was my H, and this is my M. And it makes it easier to label your statement. Yeah. But if I'm just looking for numbers, why spend a whole bunch of time labeling letters when you don't have to?
Yeah, I was doing that.
Speed through it takes a lot longer, right? Yeah. But if you could just write down numbers,
yeah, do
it. If I ask you to write down a statement, then you do. All right, so we have 32 over 68, which does reduce down to 18 over 17. Note that the 32 came from the small triangle, so the small one is going to be the top of all my fractions. Well, the x is from the small one, so I have x over, corresponds to the 32, equals the 18 over 17. Oh, wait. It should have been 8 over 17. That's way too big. It should be 8 over 17 on both of those. All right, using our means extremes, we would say, well, 17x is going to equal 8 times 32, which is 256, which means that x would equal 256 divided by 17, but my answers were only in decimals, so that would be about, so I should put my squiggly marks, about 15.06. Yes?
So if you were asking for like a triangle congruency, and look, we should put the letters,
yes,
the letters always like match up, like there's an R on the top.
Yes.
Of that triangle.
Yep, and that's why I would draw, see how I drew a 90-degree and what ones are similar here? So then I can come down here and say, oh, I had a green mark here, so that must be my R. My 90 degrees, that my H, I got that. And then I can just do that.
Okay. But the M and H are the same letters, even though they have 90 degrees, because they're like two completely different.
They're two completely different angles, yes. Because the M is coming from the red, not the full M. Yeah. Yep. All right, other questions on this one? All right, the questions from the homework. Dory.
Number 18.
Number 18. Number 18 was really a challenge question. If you didn't get it, don't expect it to show up on a test because it won't. But we'll quickly go over it. If you get lost, I'm not going to spend a ton of time on it because it was a challenge question. So if you get lost, don't freak out. All right. So we're going to deal with a whole bunch of triangles, and I didn't even draw all the triangles on there. So the first thing I noticed was we had, if you look what I'm highlighting here, we had this triangle here, which I drew right there. And then I drew the one with the flagpole that had 12, and I just put it on the other side. Now, what's important about all the numbers that I have down below is I actually split these triangles up into further triangles. So I split this triangle up into one that looked like this, where I just had the 6 and the y plus z, and I split it up into the x z triangle. Do you see those two triangles? And that's where I wrote this statement down. I said, well, x over 6 equals z over z plus y. And then I did the exact same thing for this triangle. Now, here is mostly just trial and error because you're not going to know this is true unless you can actually see it happening. So I said, well, if I take x over 6 plus x over 12, through substitution, I can replace that x over 6 with z over z plus y. So that's what I did here. So really, I just used substitution to change that into that form. Then I used substitution to say x over 12 actually equals y over z plus y. Then I actually did this addition. I said, well, they have a common denominator. If I add the numerator, z plus y over z plus y, well, that just equals 1. Well, if this section here on equals 1, then this section I have boxed in also equals 1. Because this equals this equals this equals 1. We can use the transitive property to say that x over 6 plus x over 12 does equal 1. So I put that down there and I solve for x. Is that something I expect you to do on a test? Absolutely not. It's a tough problem that kind of turns into trial and error of what would work at it. All right? Other questions? Hamza.
Can you go over number 11?
Yeah, so number 11. Let's go ahead and take a picture of number 11. So number 11, we had to use the fact. There we go. All right, we're going to use the fact that if our base equals 16, if a to b equals 16, then d to c also equals 16. So that means if this is 10, this little section from c to whatever point this is 6. Well, then let's look at the two triangles that are created. We have this triangle that I have in red that I put right here. And then I took this one that's in green, and I threw that there. Note, I put my congruent angles, and I made sure to put my congruent angles in the same spot. So all I did is I redrew this, made it a little smaller, put my congruent angle there, and then told me where to put my 6, my y, and my x. So those two things are similar. So then we could say 10 over 6 is our scale factor, which is 5 over 3. And then we could find our y by doing, well, if I did 10 over 6, then we'll do 15 over y equals a scale factor of 5 over 3, which gets us our y, and will also get us our x values.
So, how do you know the triangle? Why wouldn't you use like A, B, and then pick the unknown?
So my goal is to use any triangle that has all the bits of information that I could possibly use. So if I highlight the big triangle, and it kind of, you have to think your way through which triangle to use. So if I use that big triangle, I do have 16, but this full side isn't even labeled. It's 15 plus x. And this one is something I don't even know, plus y. I guess we could get 9 in there. So it's a lot of unknowns in one triangle. So I would just kind of put that off to the side burner and say, well, first of all, we could say that they're similar to this one, but we have a bunch of unknowns. So I'd kind of put that off to the side and say, is there something better that we can use? And then when I highlight this triangle, I'm like, oh, 10, 9, 15, I know every single side. And then I look at this one here, and I have my x, y, and maybe I'm just missing that 6, and I'm like, well, I can get this and get the 6 out here. So you're using, which triangles have the most information you can possibly use? And sometimes you pick the wrong one and you try something else later. Okay?
So with these problems, will all triangles be similar, like using every triangle? Any triangle would work?
You'd have to prove that they're similar, right?
Yes.
So this big one, this one here, compared to this DA, whatever, would be hard to prove is similar to this one straight away. Because all we'd have is that angle and that angle, and we wouldn't have any other angles.
So sometimes like one won't be similar to the other two.
Most of the time, they all are, it's just whether you can prove it or not.
Okay.
All right? And if you can't prove it, don't use it, because just in case it's not similar, then you just threw that problem off. All right, other questions? Hamza.
Can we also go over number 9?
Yeah. Number 9. Number 9, once again, I'm looking for triangles that have the most information I could possibly use, and I can prove they are similar. So you might have solved this differently, too. So I took the big triangle, which was ACB, and pulled that out. And I said that's congruent to that ADC one, because they do share angle A, right, the reflexive property, and they're both 90 degrees. So I made sure to put the 90 degrees in the same place. And I made sure to put their A's in the same place, and I labeled it as followed. Well, the scale factor between those two are 20 over 16, which is 5 over 4. And then I'll notice, following it, that we have this n in that 12. So n over 12 has to equal 5 over 4, which is going to simplify down to n equals 15. And then we'll look at that 16 plus p. Well, that corresponds to the 20. So I just did 16 plus p over 20 equals 5 over 4, and I hoped it all worked out and solved, which it did. Things canceled out, and I ended up with p equals 9. So sometimes you will have a long string of things that you just have to multiply. Sometimes it will be like 16 plus p over 4 equals 5p over something else. You might have a lot of variables. You cross multiply and hope that everything cancels out. Otherwise, you have to go back and find a different triangle.
Okay.
Okay.
I was just confused. I don't understand how you got CAB is similar to DAC. I got CAB is similar to DCA.
You CAB? Well, I showed it, actually. I said they both are 90 degrees, and they both share angle A.
Yeah.
So they have two angles congruent, so...
Yeah. I had they share angle A.
Mhm.
Like I had like DCA and then CAB. So my DCA was like on that side, like on the right side, and then my CAB, my angle A was on the left side. Does that make sense?
For these two triangles?
Yeah, basically my A and C was switched.
But on both? Oh, on this one you flipped your A and C?
Mhm.
Well, then they wouldn't match up. They wouldn't be
Yeah.
similar in that fashion.
Okay.
Yeah.
So, like how do you have like a good tip on like how to rotate triangles?
Yeah, just like I did. I drew the two things similarly first.
Okay.
So how mine would have looked before any of this stuff is on here, I would actually have not had any of these values on here. Let's just start with a blank. And I would have wrote that exact same triangle, maybe just smaller or something. Okay, so I just make it smaller. And I look at the triangle that I'm trying to draw, and that's that ADC. So I'm going to see that they both share angle A. So I'm going to put angle A in the same place because those are your congruent angles, so they're corresponding. So I mean that this has to be A. And then they both have to have 90 degrees in the same place, so I'll put the 90 degree up there. And the 90 degree for that one is, the D is down by the 90 degree that's forming it. And then I know the last one has to be C. So I would draw the picture first and then label stuff based upon what they have in congruent and general, like short side, long side, some visuals like that can help too.
So the angles have to match up, not necessarily the letters.
Right. right. If you have other questions, please ask later. We just don't have time. We got to get through today's lesson. So today's lesson, we're going to talk about two more theorems that we can prove that two triangles are in fact similar. The first one we're going to talk about is the side-side-side similarity theorem. It says two triangles are similar if and only if all three pairs of corresponding sides are in fact proportional. Remember, to show something's proportional is something like A over B has to equal C over D equals E over F. The problem with showing that sides are proportional, you have to pick sides that are corresponding to each other. And you can't just randomly pull out 27 and say it corresponds to 48 because they're on top and bottom. You can't pull out 21 and 28 and say they're proportional because they're on two sides. That's not how triangles work. The easiest way to do these and making sure things are proportional is to list which sides are your smallest to largest on both your triangles. Smallest will match up with smallest, medium with medium, and large with large. So we're just going to order from smallest to largest. Order from small to large. There's two ways to do that. First way is just write down from smallest to largest. So if I look at this triangle here, I'm looking at ALE. All right, its smallest side is 21. So for this triangle, our smallest side is 21. The next biggest side is 27. And then our biggest side is 36. Another way to list from smallest to largest is sometimes it's nice to have like a drawing technique where you can just visually see which is biggest and smallest. So knowing that 21 is smallest, one idea might be to circle your smallest side, maybe box in your medium size, and maybe put another shape by your largest, and I usually use like an asterisk by the largest. That way you can visually know which ones match up. All right, now let's look at that lower triangle. That lower triangle is APL. I'm also going to mark that this is 36. I'm going to mark the 36 on both triangles. All right, just listing them using numbers, you would say, well, 28 is your smallest side. 36 is your next biggest, and 48 is your largest. Once again, that's just one method. Another method that people like to use is you circle your smallest, you box in your medium one, and you put another shape by your largest one. I like the visual one because I'm like the ones that are circled match up, the ones that are squared match up, and the ones with stars match up. Otherwise, you can just look at it this way. Well, 21 matches up with 28, 27 matches up with 36, and 36 matches up with 48. Whatever method you use, I don't care. You just have to know which is your smallest to largest in each triangle. Now we're going to set up a proportion. Your smallest sides should be proportional to your medium sides, which should be proportional to your largest sides. So let's pair up our smallest sides. Our smallest sides would be something like 21 over 21 matched up with 28. So that is your small sides. Our next one will be our medium. Our medium sides were that 27 over 36. And finally, the large sides on each of them, would be that 36 over 48. You do not have to put them in order from large to small, but as soon as you pick one triangle to be your top, so notice that 21, 27, and 36 were all on the top, all came from the same triangle, and that 28, 36, and 48 all came from the small one. So in order to use the side similarity, that must be true. So an easy way to check to see if it's true is you just simplify each of your fractions. Well, 21 over 28. 7 goes into 21 3 times. 7 goes into 28 4 times. That's 3 over 4. 9 goes into 27 3 times. 9 goes into 36 4 times. And finally, 12 goes into 36 3 times. And 12 goes into 48 4 times. So that means they are proportional I might put a little check there saying, yep, everything works out. So PAL is going to be similar to another triangle because of side, side, side. What is that other triangle? Yeah. ELA. Let's double check that. So PAL, P goes across the longest side. I'm sorry, it was PAL. So PAL goes from P to A, which goes across your shortest side, and then it goes across the medium sides. This one, ELA, E went across the smaller side, and then it went across the bigger side. Did that match up? Grant?
No, it's supposed to be LEA.
It should be LEA. It should be LEA. Once again, P to A went across the shorter side. L to E also goes across the shorter side. A to L went across the medium side. That's why I had that boxed in 36. E to A also goes across that medium side, which was 27. That's one of the good methods of having these drawn with circles, squares, and other shapes, because then you can actually visually see which keeps everything proportional when you're doing your statement. All right, so that's side, 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 proving that all three sides are proportional to each other. Our next one is side angle side similarity theorem. That is, you can show that two angles are congruent and that two sides are proportional, but it can't be just any two sides. They have to be the sides that the angle is included. So your angle that you're proving is congruent has to be included between your two sides in order to be side angle side. So for example, if I'm looking at this one, well, to use side angle side, first you have to have an angle being congruent to another angle. So we can do that. We can just go ahead and say that angle THS is congruent to angle UHO, and that's because they're vertical angles. All right, now the sides that they show are, that angle is included between the two sides 12 and 15, and that angle that's congruent is also included between 25 and 20. So this works for side angle side. We just have to prove that the two sides are proportional. Once again, you want to list which is your smallest and which is your largest. Small over small, large over large. So between 12 and 15, 12 is your smallest. So I'm going to circle it. And maybe I'll box in the 15, saying that's my larger one. Well, between 20 and 25, 20 is my smallest, 25 is my biggest. Remember, the other method is just to write 20 is less than 25, and for this triangle, it would be 12 is less than 15. Small over small, large over large. So we're just going to go with 12 over 20 has to equal 15 over 25. Well, 12 over 20, 4 goes into 12 3 times. 4 goes into 25 times, so it's 3 over 5. 5 goes into 15 3 times. 5 goes into 25 5 times. That works out. They're proportional. So because we have our angle and our two sides, we can now use the side angle side to say that triangle HOU is similar to which triangle? So I have HOU is similar to which triangle? Cam? THS. Let's check that out. Is T congruent to H? Are the angles T and H congruent? No, they're not. So it can't be H and T. Cece? HTS. Let's try that one. So I know H is congruent to H, so we should start with H, right? Because we know those two things are congruent. All right, from H to O is across the larger side. H to T is across the larger side, so yes, it would be HTS. All right, any questions on either one of those two theorems? Okay, so we have three ways to prove that two triangles are similar. The first way is just the angle-angle. We had the angle-angle postulate that we learned on Friday. Actually, we learned it on Thursday. Then we had the side-side-side theorem, which we talked about today. And finally, we had the side-angle-side theorem, which we also covered today. So whenever I ask, are two triangles similar, you should ask angle-angle, side-angle-side, or side-side-side. Those are the three ones to pick from. All right, let's put that in action. I need to see if those two triangles are similar. Then I'm supposed to state a statement that they are similar and say what theorem I used. All right, they gave me three sides. They gave me three sides. So that must mean I have to use side, side, side. So I first have to make sure all sides are proportional. In order to do that, you need to list your sides from smallest to largest. Either you do the thing where you circle, box, and put a star, or you can list them in order, saying, 10 is less than 15 is less than 20. I don't care what method you use. And the other one, my 16 is the smallest. My 24 is my second largest. And my biggest is 32. Once again, you could have listed them in order, like 16 is less than 24 is less than 32. You probably want to just pick one of those methods and not have to do both ways every single time. All right, small over small equals medium over medium equals large over large. Let's pick our small triangle to be the top of our fractions. So I'm going to set something up that looks like 10 over 16. Has to equal 15 over 24. Has to equal 20 over 32. Well, if I divide 10 by 2 and 16 by 2, we're going to end up with 5 over 8. 15 divided by, 3? Would give me 5. And 24 divided by 3 gives me 8. So 15 over 24 simplifies to 5 over 8. 20 over 32, so I would divide, 4 goes into both 20 and 32. 20 divided by 4 is 5. 32 divided by 4 is 8. That all checks out. It's all proportional. So we can use the side-side-side theorem. And by the side-side-side theorem, we can now make a statement. I'm going to say FHG is similar to what triangle? What triangle is FHG similar to? Aryan.
XRS.
Say that one more time.
XRS.
XRS. Those S's and X's sound the same. I just had to make sure you get it in the right place. It would be XRS. Correct. Look at number 2. If I'd find that missing angle, on both of those, angle C would be 60 degrees. Angle J would turn out to be 50 degrees, because 50 plus 60 plus 70 equals 180. Are those two shapes similar? Yes or no? Sam?
Yes. Or wait, no.
Why not?
One, the 70, when you add them, get like 70 for the other 180. Yeah, 7, right.
I think there's probably a better way than adding. Are those two triangles similar? Yes or no, and why? Isabel?
No, because only one of the angles are
How many angles have to be congruent for them to be similar?
2.
Yeah.
Wait, it's 2.
Cece.
Shouldn't the top of C, wait, yes, be 7?
Oh, it should be 70. Yep, you're right. I did my math really quickly in my head wrong. But does that change anything?
Wait, yeah, no.
Isabel said that two angles have to be congruent.
If two are the same, shouldn't all three of them be the same?
Yes.
But they're not.
Hang on. Let's just start at the basic. Are two of the angles congruent between the two triangles? No. So it's not similar. Angles must be congruent. Angles must be congruent. All angles must be congruent. The reason why we could boil it down to just two is because what Hamza said, as soon as two of them are congruent, all three of them have to be congruent. All right, 3. They give me two sides on each triangle, so that must mean that it has to be side, angle, side if we want to actually prove this one. So that means the angle between the two sides must be congruent. Well, good thing is that angle RSQ and TSU are actually congruent by vertical angles. So we can go ahead and say that angle RSQ is congruent to angle TSU. And that was because of vertical angles. All right, now the sides flanking. That included angle must be proportional. Small over small must equal our large over large. So that might look something like, well, 8's the smallest on this one, so maybe I'll do that trick where I circle and I put a star by the largest, circle, and put the star by the largest. So that must mean that 8 over 6 must equal 12 over 9. Well, 8 and 6, 2 goes into both 8 and 6. That would be 4 over 3. And 3 goes into 12 4 times. 3 goes into 9 3 times. That's 4 over 3. That means they are proportional. So it is, in fact, two similar triangles by side, angle, side. I'll kick us off. Triangle, what do I want? Let's go SRQ. Triangle SRQ is similar to what other triangle? Grant? SUT. Let's see. S and S are congruent angles. S to R went S to the largest side. So S to U also goes across the largest side. So yes, it is correct. It is SUT. Chem.
So let's say if we did like SQR instead, then would it be STU?
Yes, correct. Yep. How you name the first triangle affects how you name the second triangle. All right, our next one. Can we prove these two are similar? That is the question. Well, we do have two angles that are congruent. We do have that angle WXV is congruent to angle YZX. And we do have two sides. Tell me why it'd be a waste of time to get the proportions of those two sides. Ishan?
It should be a YXZ or YZ.
YXZ, yeah. Yeah, it should be YXZ. But that's not the important part. The important part is why would doing any extra work be a waste of time on this problem? Arya?
Because we know the order is like isn't correct.
The order is incorrect.
Yeah.
I would have to know X, Y, and XV in order to be side, angle, side. In fact, right now we have side, side, angle. So we can't prove they're similar. We can't prove they are similar. Because that's side, side, angle. This would be side, side, angle. So we can't prove they are similar. All right, two more. Let's look at number 5. So I'm going to notice in number 5, we're missing something that we would need to prove all three of them are similar. Look at angle PLA. if there was a 90-degree symbol there, like I just put right there, then we could prove all three of them are similar. It isn't there. So instead, I'm going to look at the two smaller triangles. So the first triangle I'm going to look at is that triangle PNL. Labeling that, this would be 25, this would be 15, and N would be a right triangle. The other one that could possibly be similar would be that small one, that NLA, and let's see how to write that. So let's first do that. Let's do our 90 degree in the proper place. Well, the 90 degree one should have an N by it. All right. The shorter side of LNA is 9, so I'm going to label this 9. And the longer side is 15. The hypotenuse is unknown. All right, in order for those to be similar, we need side, angle, side. We already know the angles are congruent. N is congruent to N. So I just need to show that the two sides flanking it are proportional. Yeah, Hamza.
How do you know that like the top right is 9? Like the N.
I use a little logic on it. See how this is 15 and 25? 15 is the shorter side. Shorter side goes on the right side. This is 9 and this is 15. 9 is shorter than 15. I already said the shorter side has to go right here.
Oh.
Remember, shorter corresponds to shorter. Longer corresponds to longer. So this 15 has to correspond to this 9 the same way as 25 and 15. All right, because if I look at this 15 is the smaller of the sides. This 25 is the bigger. This 9 is the smaller. This 15 is the bigger. It all matches up in the drawing. So that's another way to look at your drawings is, smaller to larger sides. All right, so that means small to small would be 9 over 15. Must equal large to large, which would be 15 over 25. 9 over 15, 3 goes into both those. That'd be 3 over 5. 5 goes into both these. It turns into 3 over 5. So that works out. And we could say these two triangles are similar by side, angle, side. I'm going to label it triangle PNL is similar to, well, I said that was N. Let's label the rest of the small triangle. So our small triangle should be triangle L. Ooh, what did I start with? I started with P, went to N, so it would be L, N, A. All right, our very last one. We're given 3 sides of each of the triangles. So I'm just going to draw the pictures around it. So I'm going to circle 16. I'll put a box around 20. Maybe I'll put a star by 24. That will be DAC because 16 is less than 20 is less than 24. In triangle ACB, 24 is your smallest side. So I'll circle it. 30 is the next biggest, and 36 is your largest. So our equations to check for side, side, side would be 16 over 24. Has to equal our medians being divided. That would be 20 over 30. And finally, it would be our larges, which would be 24 over 36. If you do simplify those fractions, you should come up with 2 over 3 equals 2 over 3 equals 2 over 3. And that would all check out for side, side, side. Then you could say something like triangle DAC. So if I had DAC, I went across the box side and then the star side. So I have to go across the box side, so that'd be AB, and the star side, which would be C, so it'd be ABC, is similar to triangle ABC.